Good evening, everyone. We are Student Union's Messenger. Our group is John Schaefer, Joseph Tracy, Chris Carroll, myself, David Banks, and Trevor Carlston. So as we've discussed before, your business problem is communications are being stored insecurely. There's no centralized source for storing your IT data. Your proprietary code is vulnerable right now to theft and could potentially lead to significant loss of reputation and/or revenue. Developers need a secure way to share proprietary code without placing it on vulnerable public servers. So our proposed project is JMessenger. This will share proprietary code between developers, securely maintain and log all activities that occur on our service, help ensure reliable and safe working environment for the information stored, and it would utilize secure HTTP or HTTPS and SSH connections to maintain the security of our services. So our responsibilities will be software, will be Sarbanes-Oxley compliant by storing all the communications in a database repository. The software will allow developers to share proprietary code via usage of back-end servers. All shared code will be logged with each transmission, and we will provide documentation and basic training on the new product to your team. Big Kid Tech's responsibility is to provide a point person to work with us for initial training and setup purposes, provide a back-end database server. You're also responsible for patching this database server and for backing up this database server. We will not be handling that. Our risk analysis, as you can see from the items listed, the majority of the risks for this project are related to Big Kid Tech's internal IT environment. This plays a small part in the development of this project. Big Kid Tech only needs to host this database server. We do not need to outsource work to keep the financial risk low by reducing costs. Increases in productivity and reducing intellectual property loss far outweigh the associated minor risk, so it is our recommendation that this project be pursued. As you can see here, this is the Gantt chart that we've made of the project overview and how long we think each activity will take approximately. So our software development lifecycle in Scrum will be 2-week iterations, short feedback loops, user stories describe work, daily stand-up, iteration, retrospective kickoff, story size, story scoping, iteration showcase, and predictable software engineering. The team composition will have a project manager who schedules the tasks. We'll meet with you, the client, ensures client requests are represented in the project, and will be the point person for the customer. The Scrum Master will be the lead developer, will coordinate work of developers, will ensure work is being completed, will log work done, and will work with individual developers, and will ensure the quality of work. The developer are individuals who work on the project, will be responsible for completing assigned tasks, and will be responsible for the development of the project. Quality and assurance standards and measures. We will do regular testing of working code to ensure that there are not any exploitable leaks within the code. We'll be testing JMessenger's ability to handle large amounts of traffic. We'll be doing stress testing after the finished services to validate protection from common attacks. We're doing SQL injection testing to ensure data integrity, spike testing to determine the point of failure for the system, and SOAP testing to validate the amount of consistent performance the system can handle. So the technical problem description. Data in motion needs to be kept secure and encrypted using high levels of security like Secured Socket Layer or SSL. Confidential data at rest stored in the cloud must be encrypted using technologies such as BitLocker or comparable encryption technology. Servers need to use the certificates in SSL to communicate with each other. Systems need to be highly available, using technologies like virtualization and clustering to keep the service operable no matter what happens. The system needs to have low failure rates and utilize a monitoring system such as SolarWinds, Nagos, or comparable monitoring software to monitor the backend nodes to alert of any pending problems. As you can see, this is our UML system use case diagram. This is our class diagram. Our sequence diagram. And our state diagram. And this is the end of our presentation. Thank you for joining us. Have a good night.